Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 7th lesson on vectors, whereby we are looking at our example number 7, which is also a past Kcse question done in 2009, paper 1 question number 20. So the question is that the position vectors of points A and B with respect to the origin O are negative 8, 5 and 12, negative 5 respectively. So we need to sketch the position vector so that we are able to see what is happening. So remember, position vectors usually originate from the origin, that is the point 0, 0. So I need to sketch both my horizontal and the vertical axis. So if I let this to be my y-axis, then of course this one to be the x-axis. Of course it is continuous that way. So if I sketch the points A and B, I'm going to have the following. So point A has the coordinates of negative 8, 5. So if this is, suppose this is my negative 8, so negative 8 could be somewhere here. Then positive 5, as I'm assuming that positive 5 will be here. So that this coordinate will be somewhere here. So this is our point A. Then of course point B is 12, negative 5. So 12 could be somewhere here. Suppose this is my 12. Then negative 5 could be somewhere here. So this is negative 5. So that this coordinate is here. So these are our point B. Then because these are position vectors, remember position vectors should always be connected to the origin, which is the point 0, 0, this way. Then I also connect the other coordinate to the origin. So this is point 0, 0, should be connected to point B. Then I also connect point A to the origin, the point 0, 0, this way. So this one is just a rough sketch of what is happening. So point A, we are told that it has the coordinates position vectors of negative 8, positive 5. Negative 8, positive 5. Then B has 12, negative 5. So this is 12, negative 5. So these are the position vectors respectively. Then we are told that M is the midpoint of AB. So if this is the O, remember this is the origin point O. So AB, so it means that we need to connect. We need to connect these particular points. Point A and B are connected by a straight line, which we are calling the line AB. Then you are told that M is the midpoint of AB. So M is somewhere here, the midpoint. So this is our point M. Then we are further told that N is the midpoint of OA. So remember, OA is this line. So its midpoint could be somewhere here. So this is our point N, which is the midpoint of OA. Then in part A of the question, we are told to find Roman 1. So part A, Roman 1, they want us to find the coordinates of N and M. So it will simply be the coordinate of the midpoint. So remember, the origin is usually the point 0, 0. Therefore, its position vector is 0, 0. So if I start with the coordinates of N, because N is a midpoint, remember if you want to find the coordinates of the midpoint, we usually use the formula. You take x1 plus x2 over 2, then into brackets, comma, y1 plus y2 over 2, where x1, x2, y1, y2 represents the respective coordinates that are giving us the midpoint. So if I consider the line ONA, so if I consider this line here, this is the point O, which is 0, 0, or the origin. Then this is N is in between, whose coordinates are not known. Then we have the point A here, which has position vectors of negative 8, 5. So this one simply means that the coordinate for the origin, point O, is actually 0, 0. Then the coordinate for point A is actually negative 8, then 5. So we are going to label. This one will be our x1, then this will be y1, then this will be our x2, then this will be y2. Therefore, the midpoint, which is actually N, is going to give us. So the coordinates of N should be given by, so we take x1 plus x2 over 2. So my x1 is 0, then plus x2 is negative 8, so minus 8, then divided by 2, comma, y1, my y1 is 0, so this is 0, then plus my y2 is actually positive 5, then divided by 2. So of course this one will give me the coordinates of n as negative, that is 0 plus negative 8, I'll get negative 8, negative 8 over 2, I'm going to get negative 4, then comma, 0 plus 5, you'll get 5, then 5 over 2, you're going to get 2.5. Therefore, the coordinates for point N, these coordinates are actually negative 4, comma, so this is negative 4, comma, 2.5. Then we also look for the coordinates of the other point, which is actually the midpoint, which is point M. So we also look for the coordinates of M, so using the same formula. So the coordinates of M will be given by the following. So M will be given by, so the same, I'm going to consider the line AMB. So if I consider this particular line here, this is my A, then M is in between. This is M, then this is B. So the coordinates for point A are negative 8. So the position vectors are negative 8, positive 5. Then M, we don't have the coordinate. Position vectors of B are 12, negative 5. So this is 12, negative 5. So it means that the coordinate for A is actually negative 8, 5. Then the coordinate for B is actually 12, negative 5. Therefore, it simply means that this will be my x1, then this will be my y1, then this will give us x2, then this will be y2. Therefore, the midpoint will be given by x1 plus x2. x1 is negative 8, so negative 8 plus x2 is positive 12. So positive 12 over 2, then comma, y1 is, my y1 is positive 5, then plus my y2 is negative 5, so minus 5, then divided by 2. So this one should give us the midpoint, which is actually the point M, which is actually the midpoint of the line AB. So this will be equal to, so I'm going to get negative 8 plus 12, I'm going to get positive 4. So this is 4 over 2, comma, this will be positive, that is 5 plus minus 5 will be 5 minus 5, which is 0 over 2. So this one is going to give me 4 over 2, I'm going to get 2, comma, 0 over 2, I'm going to get 0. Therefore, the coordinate for point M is actually 2, 0. M is 2, 0. Therefore, those are the coordinates for the points N and M. Then we move to part, that is part B of the question. So in part B, we are told to express NM in terms of OB. Before that, we have Roman 2 of part A. So Roman 2 of part A, we are told to, so this is Roman 2 of part A. We are told to find the magnitude of NM. So in order for us to find the magnitude of NM, so we need to find the vector NM, whereby we'll take the coordinate of point M, then we subtract the coordinate of the point N, which will be given by, so M, or M is just the coordinate for point M, which is 2, 0. So M is actually 2, 0, it's a position vector. Then minus the position vector of ON will just be the coordinate for point N, which is negative 4. So this is negative 4, then 2.5. Negative 4, 2.5, which is the same as saying this will give us 2 minus 4, then 0 minus 2.5. So this one is going to give us, so this one will give us 2 minus 4, I'll get positive 6. 0 minus 2.5, I'll get minus 2.5. So this is the vector NM. So that is our vector NM. Then we also need to find the other vector. So let me separate this with the a line here, a straight line this way. Then remember we are asked to find the magnitude of nm, so we found nm, therefore the magnitude, also called the modulus or the length or the distance, nm, we usually denote it with this bars. When you want to find the magnitude, you take the square of the x coordinate plus the square of the y coordinate. So the first coordinate here, this is what is representing our x coordinate, then the second coordinate will be y. Remember, if you are to write the coordinate, it will be 6, negative 2.5. Therefore, this will be the x, then this will be the y coordinate. Therefore, the magnitude will be given by the square root of the x coordinate is 6, so this will be 6 squared, then plus the y coordinate is negative 2.5, then this should be squared, of course, under a bracket. Then I can close it using curly brackets. So this will be equal to the square root of 6 squared, I'm going to get 36, then plus negative 2.5 squared, I'm going to get 6.25. So this is 6.25, which is going to give me the following. So this will be the square root of 36 plus 6.25. I'm going to get 42.25. Therefore, the square root of this is giving me 6.5. So this is 6.5 units. 6.5 units. So that is the either the magnitude. The other term is modulus. Modulus. They can also use the word length or simply the distance. So those are the possible terms that can be used to substitute the word magnitude. Then in part B, that is now we are told to find the vector nm. The vector that is express the vector nm in terms of OB. So we need to compare those particular two. So this is part B of the question. So in part B, we are told to express nm in terms of OB. So we simply compare their magnitudes. So because we already have the magnitude of nm, I'll also find the magnitude of OB. So to find the magnitude of OB, I need to find vector OB, which is the same as saying taking the coordinates of point B, then you subtract the coordinate of point O, which is just 0, 0 or simply O. So this will be the coordinate for point B. So OB is just the coordinate of point B. Point B had the coordinates of 12, negative 5. So this is 12, negative 5. Then minus the origin, of course, its coordinates are 0, 0. So this one will just be 12. So this will remain to be 12 minus 0, you'll get 12. Negative 5 minus 0, you'll get negative 5. Therefore, it means the modulus or the magnitude of vector OB will actually be given by, you take the square of the x coordinate. So this should be x squared plus y squared. Of course, this one, it means its coordinate is 12, negative 5. So this is the coordinate. Remember, this one we call it the position vector. This is the position vector when it is written vertically. Then when you write it horizontally, then it becomes a coordinate. So these are coordinate. So this is the x coordinates and this is the y coordinates. Therefore, if I connect those two, I'm going to have the following. So the magnitude, which is OB or the modulus of OB, will be given by the following. The square root of the x coordinate is 12. So this will be 12 squared, then plus the y coordinate is negative 5. So I also square this. Then I can close using curly brackets here. So this will be the root of, if you take 12 squared, then plus negative 5 squared, you are going to get 169. Of course, the square root of 169 is going to give you 13. So OB is 13 units. 13 units. Then we are told to compare those two. We are told to express. So we need to express. nm in terms of OB. So we need to express nm. So this is nm in terms of OB. So I'm simply going to compare these two. So I'll let a certain scalar to be a multiple between those particular two. Therefore, I'm going to have the following. So my NM, I found NM to be 6.5 units. The magnitude of this, I'm simply going to compare the magnitude of these two. So I'll let a scalar to be a multiple between these two so that I find the value of K. So the magnitude of NM is actually 6.5 units, which should be equal to K. The magnitude of OB, we had found it as 13 units. So this is 13 units. Therefore, it simply means that if I want to find the value of K, I'll divide through by 13. I also divide through by 13. Therefore, K will be equal to, if you take 6.5 divided by 13, you're going to get a half. So it means that my value of K is a half. Therefore, it means that NM can be written as NM is equals to K or B, which simply means that NM will be equal to, so my NM, the vector NM will actually be equal to K or B, but my K is a half, so this will be a half of the vector or B. Therefore, we have expressed NM in terms of OB. So NM is equals to a half of OB. Remember, if the question was maybe express OB in terms of NM, the answer will be OB will be equal to 2NM. You simply multiply through by 2. Then we move to part C of the question. Whereby we are being told to, so in part B, they want us to find, that is in part C, we are told that P, point P maps P prime by this translation. Then given that OP is OM plus 2NM, find the coordinate of P prime. So we first of all need to find the coordinate of P. So OP, we are told that OP is equals to OM. So this is OM plus OP is OM. So this is point M. OM. So this is OM. Then of course plus 2mn. So this is the equation. So I'll simply substitute. I need to have OM. So remember OM, we need to find the value of our vector OM. OM simply means you take the coordinates of M, then you subtract the origin. So this will just be the coordinates of M was 2, 0, as indicated on the diagram here. Then minus the origin, of course, is 0, 0. So if you subtract these two, you are going to get 2, 0. So OM is just 2, 0. Then we also need to have MN. We need to have MN. Of course, we have, so for us to find MN, we need to have the following. So MN will be given by, you take the coordinates of N, then you subtract the coordinates of M. So this will be given by the coordinate for point N. N had the coordinates of -4. So this is -4, 2.5, -4, 2.5. Then minus the coordinate for M. M is just 2, 0. So OM is just 2, 0. So if I subtract these two, I'm going to have the following. So this will be -4 minus 2. I'm going to get -6. Then 2.5 minus 0, I'll just get positive 2.5. Therefore, if I substitute the values in this particular equation that I was given, remember OP is just the coordinate for point P. So it means that OP will be given by OM, of which OM I've found it as 2, 0. So this is 2, 0. Then of course added 2 into MN. MN I've found it as -6, 2.5. So if I open this bracket, I'm going to have the following. So on opening the bracket, this is what I'm going to get. So I'm going to have OP being equal to 2, 0. So this is 2, 0. Then we are going to add. So if I open this bracket, I'm going to have 2 multiplied by -6. I'm going to get -12. Then 2 multiplied by 2.5. I'm going to get +5. So this is +5. Then if I add the vectors, I'm going to have the following. I'm going to have 2 plus -12. then 0 plus 5. So of course this is going to give me the value of OP as 2 minus 12. You are simply going to get negative 10. So this is negative 10. 0 plus 5, you will get positive 5. So that is our vector OP, which is the same as. So it means the coordinate for point P is actually negative 10, 5. So those are the coordinates for point P. But the question does not want us to find the coordinates for point P. Instead, the question wants us to find that point P maps P prime by this translation. So remember, when you take the coordinates of the object plus translation, it should give you the coordinates of the image. So because P is the object, its coordinates are, so it means if we take P then plus the translation that we are given, it should give us the image, of course, which is P prime. So we are told to find the coordinates of P prime. So this one will be P, which is the object. We have found its position vector as negative 10, positive 5. Then if we add the translation, which we are given as negative 5, positive 8, then these two should give us the image, which is P prime. So if you take negative 10, so this is negative 10 plus minus 5, then 5, then plus 8. So this one should give us P prime. Therefore this will be negative 15. That is because this will give you a minus. So this negative 15, then this is positive 13 as our P prime. Therefore the coordinates of P prime, coordinates should always be expressed in horizontal form. This one is a position vector. This is a position vector. So it means, which can be written as OP prime. So it means that the coordinate of P prime will actually be 15. That is negative 15, comma positive 13. So these are the coordinates, coordinates of P. So whenever you are told to find the coordinates, they must be expressed in horizontal form. So in our next class, we'll be looking at further examples on vectors. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very